Here's the solution to quiz number 2 for ECE 321, Analog Electronics. This quiz covers sensors and calibration. The first problem is given a thermistor and a voltage divider. Find the resistance of the thermistor and the temperature, given that you're reading 2.2 volts at X. So starting out, by voltage division, the voltage is your RT over R plus RT. R is based upon your birth date. For me, be 1414 ohms, or Mother's Day. Oh yeah, okay, so 2.2 volts is R1 over R1 plus R2 times the input voltage. Solving backwards, RT is your 2.2 volts over 10 minus 2.2 times R. It'll be 398 ohms. Then back over here, if you plug in 398 ohms and solve for the temperature, you'll get 77 degrees Celsius. Problem 2 looks at, take that thermistor and put it in a circuit so that I output minus 10 volts at minus 10C and plus 10 volts at plus 40C. So the first step is to find out the resistance at minus 10C and plus 40C. R is based upon your birth date, so that'd be 1414 ohms. At minus 10C, plug it into the thermistor equation, this guy right here. What you're going to get is 17.9 kilo ohms. By voltage division, it's RT over R plus RT times 10 volts, 9.26 volts. So this goes 9.26 volts on the high side. That should go to minus 10 volts. At plus 40C, R is 1576 ohms. Calculate the voltage here. It's 5.27 volts. And that's supposed to go to plus 10C, or plus 10 volts. As the input voltage goes down, the output goes up, so connect to the minus input. The output should be 0 halfway between, so halfway between these two, take the average, you get 7.68 volts. And the gain that you need, output changes by 20 volts as the input changes by 4 volts. The gain is 5, so a 5-to-1 ratio. So this is a circuit that will output minus 10 volts at minus 10C, plus 10 volts at plus 40C. On to problem 3. Problem 3 is a strain gauge. If I have a metal beam that's 14 millimeters wide, 3 millimeters thick, and I deflect it by 15 millimeters, what's the strain on the outside edge? And what's the radius of curvature? So again, here's the radius of curvature, and the center line. This will be R, this is 15, so this is R minus 15. This is half the diameter, or half the length. This is half the length. So for a right triangle, I have d over 2 squared plus r minus 15 squared equals r squared. Solve for r, and you get 16,669 millimeters. The strain then will be the change in length for the outside edge versus the center line, and that's really just a ratio of the radius. So I'm going to go plus 1.5 millimeters, going from the center line to the outside edge. That's how much the length increases, or the radius increases. The circumference is 2 pi r, so it'll be proportional. That much relative to 16,669 millimeter radius gives you the strain. On the outside edge, it'll be plus 0.000899, this ratio. On the inside edge, it'll be minus that. It's problem 3. On problem 4, suppose I have a strain gauge that has this resistance versus strain. Come up with a circuit that outputs 0 volts at 0 strain, 10 volts at plus 10 strain. Well, again, I pick R from my voltage divider, find RT at the two endpoints. At the left endpoint, I'm at 1,000 ohms. Right endpoint, I'm at 1021 ohms. Again, you just plug in 0.01 strain into this equation, find R, and you get 1021 ohms. For voltage division, this goes from 4.13 volts to 4.19 volts. And here we really need to keep the decimal places. That's going to have a big impact on the results. The offset should be 0, or the offset is when the output is 0, the two sides A and B are the same. So the output should be 0 when the input is 4.13 volts. So that's my offset. The gain is the output changes by 10 volts as the input changes by 0.06-ish, 194 to 1. So pick that to be 194 to 1. And as the input goes up, the output goes up. Connect to the plus input. So this circuit will output 0 volts at 0 strain, 10 volts at plus 0.01 strain. Problem 5 is a linear or calibration problem. I've got a thermistor and a voltage divider, so the voltage versus temperature is going to do something. Come up with a straight line curve fit. Now, if you don't have MATLAB, what you can do is just do the endpoint calibration. Find the voltage temperature at -10, the voltage temperature at +40 Celsius. Come up with a straight line to approximate it. If you do have MATLAB, it's actually a lot easier. Just have the temperature go from -10 to +40, calculate the resistance at each point, calculate the voltage at each point. Now set up your basis as voltage and 1, and then do a least squares curve fit. Inverse B transpose B, B transpose Y, where Y is your temperature, gives the linear curve fit, so that this would be A and B. And here's your curve fit. For a parabolic curve fit, it's really the same problem. The only difference is change my basis. So now my basis is V squared, V, and 1. Solve, I get 3 terms. The first one is times V squared, the second one is times V, and the third one is times 1. So that is quiz number 2 for ECE 321, Analog Electronics.